So, welcome everybody. Today I'm going to present a joint work done with Gianluca Pozzato concerning the development of a cognitively inspired reasoning system exploited in two different applications. So the first one concerned the realization of a goal-oriented framework for automatic knowledge invention and creative problem solving, and the second one concerned the development of a logic-based recommender system for content generation exploited in the context of a replay platform within a collaboration done with the Research and Technology Center of RAI. So the general idea is to show how insights coming from cognitive research can be usefully integrated in the context of different AI applications. So the main idea of our reasoning framework is that knowledge invention in humans and machines can be really seen as a process of creative, common sense based concept combination. Now, this combinatorial and generative assumption requires to address an open problem in current research in AI and automated reasoning concerning the problem of reconciling a compositional generative procedure with the common sense or typicality based reasoning. Now, this issue is paradigmatically exemplified by the pet fish problem. This problem highlights how a human-like common sense concept combination works. And it shows in particular how when we generate novel concept, we are able to deal with this strange compositionality. It is a strange compositionality since prototypes, so common sense representations of a given concept, are not really compositional. For example, if we try to generate the prototype of a pet fish by starting from the prototypes of what is a pet and from the prototype of what is a fish, we see that the prototypical pet fish inherits some features but not all the features from the two composing concepts. So this means that there are some inheritance blocking mechanisms. Now, assuming that knowledge invention is based on this process of common sense concept combination, means being able to deal with such issue that is really pervasive in human cognition. In order to do that, we have developed TCL, which stands for Typicality-Based Concept Combination, which is a non-monotonic description logic of typicality based on three ingredients: a description logic of typicality AIxIA plus T, developed by Giordano and colleagues, that allows to reason on exceptions to inheritance and allows to equip axiom in a knowledge base with typicality inclusions. This logic has been extended with the Disponte semantics. So in this way we are able to equip these typicality inclusions with probabilities, with degree of belief, and in particular the Disponte semantics, which is developed by Reboot and colleagues, allowed us to reason on typical probabilistic scenarios in the context of concept combination. So in this way we are able to rank all the 2 to the power of n scenarios generated that consider all the possible combination of the features of the concepts to be combined. Finally, this probabilistic extension has been also equipped with an heuristic coming from cognitive semantics, which is known as head modifier heuristics, according to which in the process of concept combination there is always one head, which is the stronger element of the combination from which we want to inherit more features, and one or more modifiers. So the details of how all these elements have been integrated are provided in the paper that you see in the slide. But this integration allowed us to provide a working pipeline where, starting from a knowledge base equipped with the probabilistic real data, we were able to generate all the different to generate and rank all the different probabilistic scenarios, so all the different possible combination, and we were able to select, by using the head modifier heuristic, the most appropriate scenarios in a way that is compliant to the human-like concept combination activity that we have seen in the pet fish problem. Now, this framework has been first integrated within a goal-oriented knowledge generation system, where, starting from a knowledge base K expressed in the logic TCL, given a goal B expressed as a set of properties to be fulfilled, the system that has been developed is able to find a solution to the goal G, either if there is already a concept in the knowledge base that is able to fulfill all the criteria provided in the original goal, or if it is able to exploit the TCL combinatorial logic in order to find a combination of at least two concepts, C1 and C2, occurring in the knowledge base that are able to generate a novel concept that inherits all the features, all the properties that are required in order to fulfill the goal criteria. So this system has been tested in a task of concept composition for a knowledge base of the domestic objects. This is a particularly challenging task from a creative point of view, because only humans, ravens and other few primates are able to invent novel objects by combining, let's say, some other objects that they already have in their let's say, knowledge base, in their memory. So given a knowledge base expressed in this way, and given a set of goals expressed as a set of properties, our system was able to generate combined, so to generate combined concepts that were able to satisfy the original goal. For example, in the context of the goal number 2, where the goal was that one of finding an object that was graspable and able to launch other objects at distance, our system was able to suggest that the two concepts to be combined were the concept of branch and the rubber band, in order to provide a sort of slingshot. And we have done this for a bunch of goals, and we have evaluated also the answers provided by humans for the same kind of task, and there is a good degree of overlapping for this kind of work. Additionally, our system has been also integrated in Denoter, which, as I mentioned, is a content generation and content suggestion system. Here, the TCL reasoning framework plays the role of the inference engine within a system that is composed also by other modules. In particular, there is a crawling module and an extraction module, where, starting from the multimedia items which are available in the context of the replay catalog, we were able to extract in a frequentist and data-driven perspective all the, let's say, main features characterizing the genre to which these multimedia content were belonging to. For example, in this case, we were able to generate the knowledge base, the TCL knowledge base of the genre drama by using this frequentist data-driven perspective. And we were able to use TCL in order to create novel genres, so novel hybrid classes. For example, the class of drama or kids related content. So in order to do that, we exploited exactly the reasoning framework that I mentioned before. And the novel generated classes were then used in order to reclassify the original documents that were available in the replay catalog. This reclassification then led to a recommendation. So the idea is that particular classes of users could have been more interested in this kind of hybrid novel classes that were generated by using TCL. We have tested our system in a threefold evaluation. First is entirely automatic, so on an average, the 3.9% of the whole replay catalog items were reclassified. Then we did a user study involving 20 persons in order to ask them their opinion about the suggestion, the recommendation that they received based on the reclassification that we provided, and the average is of 6.5 out of 10, so it's quite good. And finally, we did an expert interview with Rai that pointed out some features to improve. For example, the fact of not allowing the recommendation of very old episodes, for example, episodes of movies or of series done before the 60s, or the possibility of expliciting also negative preferences for the users. For example, I do not want to see kids-related content. So the idea is to have a combination of classes, also considering these negative issues. And this is something on which we are working on currently. So the main upshots is that I've showed how the TCL cognitively inspired common sense reasoning framework has been applied in the context of two completely different applications. This combinatorial logic can be used for more application, we believe, since it models a very ubiquitous phenomenon in human cognition, and we plan to extend the application of the system to other domains such as museum recommendation, music, and so on and so forth. So, thank you very much.